Okay, hello everyone. Welcome to the first Singularity CE community call for 2023. Today we're going to mostly concentrate on talking about Singularity CE 3.11, which is the upcoming release. There's a release candidate out at the moment. So if you hop over to the releases page on GitHub, and you have to kind of click through to this page because it won't show you pre-releases on the home page of the repository. Then if you scroll down from the top underneath the stable release, you'll find the details of 3.11 release candidate 1. So in previous calls over the past 6 months, while this has been developed, we've gone through some of the features and demonstrated portions of the new functionality which is in this version. What I want to do today is just have a very quick look through this list, and then I do some demos and show some of the new features in 3.11. So please interrupt me at any time to ask any questions about the scope or limitations of those, what systems they apply to, and so on. So in the release notes, you will find that there are some changed defaults and behaviors. These are worth highlighting because they might affect existing users. The first one here is related to us planning to remove in Singularity 4.0 the ability to have what are called image driver plugins. So Singularity internally handles container images or overlay images through some code, which can be extended through the use of plugins. Now, because of our plans to expand our OCI compatibility with an OCI runtime, we want to have functionality which works across the OCI mode and Singularity's native mode. And the plugins don't really work in the OCI flow. So we're planning to deprecate these. What we have in 3.11 is that the functionality supported by the only plugin that we kind of distribute has been replaced by inbuilt functionality. So in Ubuntu, there was a way of dealing with overlays unprivileged without root privilege. This has now become widespread and in the mainstream Linux kernel, so we don't need this plugin so much anymore for that function. So although we're removing something here or planning to remove it into 4.0, there's not a great deal of impact. The further down the list of changes, the second point is that if you have a new enough kernel on your system and you run in the user namespace mode or the unprivileged mode, then we're going to use the new unprivileged overlay functionality in the kernel to construct the container using an overlay layout instead of an underlay layout. Now, again, this is something you probably won't notice very much unless you do loads and loads of bind mounts, in which case you'll see when you look into the container and at the mounts in the container that things are layered and constructed a bit differently. If you've been using the OCI functionality up to 3.11, then we've underneath been using runC as our low-level OCI engine for the OCI commands. Now we've switched to prefer crun as an alternative to runC, but if crun isn't available, we'll use runC. This fourth point here, when you use a writable tempfs, or you isolate the temp directory and home directory and other things using the contain all flag when you run a container, Singularity creates temporary in-memory file systems to hold changes to the container or that other stuff. We've bumped the default size for those temporary file systems up to 64 megabytes now, so you have fewer problems running some containers which want to write temporary files onto the container file system. And then this last point, I'm actually going to cover in the demo because it's easier to see there. So generally, the change defaults and behaviors aren't major things. And what we do have in 3.11 are then a bunch of new features, new options for existing features, and an entirely new mode of running containers. So I'll get onto that very shortly. At this point in time, if you go to the documentation pages at the Sylabs website, the documentation for these new features are found in the main guide. So the main branch is where we do development, and the main branch of the documentation is where these new features are being added at the moment. So if you want to try out the release candidate and you're looking for documentation on, say, unprivileged builds, then in the main branch of the documentation, you will find the new topics here. As we move towards a full release, that documentation will be available under the 3.11 links on the documentation page once those are put in place. The thought is that this release will probably happen either Thursday or Tuesday, the next Thursday or Tuesday from now. So about a week or just over a week's time. All right. Any general questions while I switch over to my terminal and I can do some demonstrations of some of this new stuff? Nope. Okay, I'll jump right in then. So the first thing I want to show is that we can now build containers without root in another way. So if you have a definition file for a container, and we'll look at a simple one here. Typically, for kind of simple containers, you're going to start with a container image that exists already from Docker or maybe the Singularity Container Services library. And in the post part of the definition file, you're going to add some additional software with the standard package managers for the Linux distribution you're using. So in Ubuntu, you might use apt or apt-get to install some extra software. And the usual way which we've built containers up until now is on a local system to run Singularity build with sudo, so that you become root on the system and then you're root in the container. So apt-get or yum will work during the build. We've had for a while now a fake root option, which if the system is set up with user namespaces and what are called sub-ID mappings, you can have kind of a fake root user inside the container. But not everywhere is able to configure their systems to support fake root. So we also have remote builds where we offer the cloud Sylabs.io remote builder service, which you can submit a build to, or people can use Singularity Enterprise as the kind of commercial hosted, self-hosted version of that, which Sylabs provides. There's still kind of gaps there for some people using older clusters or where user namespaces can't be enabled or ID maps can't be enabled, and remote builds might not fulfill the need. So in 3.11, we've added functionality to be able to perform simple builds, not all builds, from definition files without privilege and without sudo. The way this works, if I go ahead and run the build, we'll see is that it comes up with an info message that we're using proot to build unprivileged. Now, proot is a utility which you can download and install quite easily. It's available as a static binary on the web. And if Singularity is able to find it, it can use this proot utility to actually impersonate root inside the container build. And it does that in a sort of limited way. It can't emulate everything that a real root has. And the reason for that is it's kind of trapping calls that programmers make and kind of rewriting them as it goes. Whereas the fake root is setting up a namespace, and it has full support in the kernel for the type of operations that a root user gets to do. So you can use proot to build simple definition files where you start from a container and you add software, and you can build these successfully without root. I say that, and what we're seeing here is that the Ubuntu mirror, which it's connecting to, is gone extremely slow. So we're only getting 42K a second there. So what I need to do to carry on here is copy the one I made earlier. If the Ubuntu mirror was working fine, we'd see this container build, and then I would run it for you, and I show that we built without root and everything worked. But one I did earlier, which I ran in exactly the same way. Oh, sorry, built in exactly the same way. There it is, it works properly. So this is a useful feature for people on some clusters and systems where fake root isn't available, and maybe the remote builds don't solve the particular needs you have. Any questions on that? Okay, we'll go on now to some signing and verification flows. So up until now, Singularity has supported signing and then verifying CIF images through the use of PGP keys. So you can generate a key pair, and then you can sign a CIF image with the private key, and anyone who has access to the public key can then verify that the image is still intact, hasn't been tampered with. What we have in 3.11 now is the ability to sign not just with a PGP key, but a key in PEM format. So if you've played around with OpenSSL to create certificates and things, you'll have come across PEM format keys. What I'm going to do here is just sign the image I created and pass the sign command a key flag and point it at a particular private key I have available here. And now instead of using PGP, it's using the specific PEM format key that I've provided. The other way around, the verification, I go about that by doing Singularity verify and just passing the public key that I need to use to kind of verify the container. So same things kind of under the hood really happening as with PGP keys. The signature is in a different format. It uses something called DSSE, or the Dead Simple Signing Envelope, so that we can be more generic in the type of material that's used to generate the signature and how we store it. The next kind of step from verifying with a public key in PEM format is if we have a certificate which is been generated from our private key in some way. So people are often kind of familiar with this when they set up web servers. You set up, you generate a private key, and with that you generate a certificate signing request, and that gets processed either by yourself or some kind of certificate authority, and you end up with a certificate. And the certificate is something that can be used, in this case, instead of directly a public key, to verify the container. Now, usually when you're working with certificates, you don't necessarily have a single certificate, but you have a chain. So I've got a command here, which is asking to verify my CIF image. And I'm asking it to use a certificate called leaf.pem. So this is the certificate at the end of my chain. And in turn, my leaf certificate is kind of validated by an intermediate certificate, which I've provided here. And then the intermediate is ultimately trusted because it's been signed by a root certificate down at the bottom. So if you've kind of set up web servers for HTTPS, you'll be familiar with this. We can apply it to signing containers or code and things, as long as the certificate has been generated so that it's allowed to be used for code signing. So I've got this certificate chain which kind of fulfills the requirements, and now I can verify my CIF using the certificate chain rather than a key directly. The reason I've got two outputs here is because I took my, here's one I did earlier, CIF image, and I signed it again. So it's actually been signed twice, and we're verifying for both of the signatures. Generally, you'd only see one output here. Any questions on that? Okay, staying in the vein of kind of verification and signatures, then the next step is that if we're using certificates to verify container, then certificates are able to be revoked. And there's a standard, a protocol called OCSP, which provides a way of the issuer of a certificate being able to declare the location of an online service, which you can check in order to find out whether the certificate's been revoked. So we had a collaborator, Fotis, worked on this functionality. He did the work so that Singularity Verify now has an additional flag you can specify called OCSP Verify. And what this will do is it will work its way down the certificate chain. And whenever a certificate declares that there's an OCSP responder, which will tell you whether that certificate has been revoked or not, it will call out to the responder and check whether it's been revoked. And the idea is that, say, something got compromised around the infrastructure that provided me the intermediate certificate here. It could be marked through OCSP as revoked. And then when you try to verify this container, Singularity will call out to the OCSP responder, and it'll be able to find out that information. And then the container won't be considered verified because the certificate in that chain is no longer valid. I hope to have a demo of this, but I can actually make my OCSP setup crash on my machine, and I didn't get that fixed quite in time. So I'm just going to run this, and what we'll see is that in this case, it's trying to reach out to an OCSP server to validate the relationship here and check that there's no revocation of the certificate. But the server isn't running because it's unfortunately crashed on my machine. For that reason, though, the verification has failed. Okay, so if we can't prove that the certificate hasn't been revoked by talking to the OCSP responder, then we don't consider the container verified. Any questions on this stuff? I should also kind of defer to Adam, if he's on the call about this, but any questions? All right, we'll go on to the next little bit. If I clean up my terminal here, we're going to move on to instances. Now, with Docker and other runtimes, you commonly start a container and it sits in the background running some kind of service that you connect to. With Singularity, you usually run or shell or exec something in a container in the foreground. But you can run a service in the background as an instance. And this has been available for a long time. We can say instance start. And here I've started a kind of URL to PDF service where I can pass it the URL of something and it'll spit out a PDF rendering of the web page there. What's new in 3.11 is that when we start an instance, if we can, so if we're running the instance as root or our system uses cgroups v2, the container, the instance container, will be started inside a C group, a Linux control group. And what this allows us to do now is introduce the Singularity instance stats command, and we can watch the resource usage of instances. So we didn't used to be able to do this because there wasn't a way to kind of isolate the usage of the instance from other processes on the system because we didn't isolate as much as Docker and so on. But now we're putting the instance in the C group when we can. If I drop down into another terminal somewhere and actually make a request to the service here that's running in the instance, we can see PIDs are spinning up and we've got CPU usage, and now it's finished. So we can use instance stats now to see what's going on. The other change to instances, if I stop this one and start it again, I can specify resource limits to my instance start command. So here I can say this instance is only allowed to use 2 CPUs, or perhaps we can say you're allowed to use a quarter of a CPU. So let's start it with a resource limit of CPUs 0.25. And if we go back and we monitor the instance, we'll see it kind of starting up and getting settled. If I make an API request now, what we'll see is that the CPU usage kind of tops out around 25% because we've asked the system to restrict the C group that the instance is in to 0.25 of a CPU. So this is kind of extending the C group's resource limit support, which was added for the interactive mode in 3.10 through to instances in 3.11. Any questions on that bit? Okay, we'll move on to the final piece I want to kind of spend some time on. In previous sessions, we've talked a lot about how the roadmap for Singularity is looking out to more OCI compatibility and running OCI containers in native formats so that we really have the ability to be compatible for all OCI images once we get to 4.0. In 3.11, we've got a new mode for Singularity run, shell, and exec, which is enabled by this --OCI flag here. And what we have is a completely different runtime mode, where when I say run --OCI and pass a Docker image or another OCI image, Singularity isn't using a kind of CIF translation here. It's taking the OCI image and it's running it directly from disk in an OCI bundle format. and it's using under the hood a low-level OCI runtime, in this case run C, to actually kick off the container. So we're using similar low-level OCI runtime to other OCI tools now. No translation to Singularity's native format. We're not using Singularity's native low-level runtime, but we've preserved a lot of what makes Singularity easy to use compared to Docker and so on. So I'm in a full OCI container here, but I drop into my home directory. I'm by default the same user in the container as I am out on the host system. For 3.11, we've supported quite a lot of the most common flags that you can use with the run, shell, exec commands in this OCI mode. So here you can see I've got the OCI mode turned on. I'm also using fake root to drop into the container as a fake root user. I'm going to bind in a path, and we can see that if I start it, I'm root here, and the path that I asked to bind is also there. So most of the kind of standard operations which you do with Singularity containers will work directly on native OCI containers with the --OCI mode. In the release notes, there's a big list of things which work, and conversely, things which don't work. So you can't at the moment deal with all the support for overlays and things like that. Those features are going to be added as we progress through to 4.0. If I want to use environment variables, I have the same ability to export Singularity env environment variables, or I can use the env flag or an env file. If I have a look at the environment when I run a container, we'll see it's quite minimal. And the reason for this is that we're shooting for OCI compatibility, but the broad kind of functions by default that the Singularity command line has led people to expect. So we drop into the home directory and so on, as I said, but we are achieving an environment which is much closer to Singularity's native runtime with the compat flag than when you run it without any flags at all. So you'll see here that OCI at the moment is sort of even cut down compared to the environment when you run in the native runtime's compat mode. Lots of the Singularity specifics here, which are related to our own runtime and container format, aren't present when you run a container in the OCI mode. One of the big things that using OCI mode allows is better compatibility with things you can put in Docker files that Singularity doesn't really have a concept for in its definition files, and therefore doesn't support when you run a container. In a Docker file, I can have a line which starts user, which instructs Docker that when I enter the container, any commands I run and things should be as this user. So in this Docker file, I've just got an Alpine image from Docker Hub, and I'm adding a test group, and I'm adding a user to that group. Now, if I save this to a Docker archive, I can run it with Singularity. And by default, if I run the container, it's going to run this ID command. And we see that although I ran this container, which was declaring user, test user, it actually didn't respect that at all. It's not conforming to the OCI configuration, which is behind this Docker container, and it's just running it as the user on the system. In the OCI mode, we're now able to support things like user a bit better. So we can see that when we run this same Docker container in the OCI mode, we actually are the test user and the test group inside the container. The way this is working is using user namespaces and sub-ID maps, so that although I'm user 2000 in the container, I'm still the same user outside of the container. So we don't introduce any kind of strangeness with creation of files and access permissions and so on. But we're now able to run containers in OCI mode, which really depend on the software inside running as a very specific user, which was declared in the Docker file when they were built. Okay, any questions at all on the things I've covered? That's about it for what I had planned out to show on CE 3.11. Like I said, we'll get the full release out as soon as possible, probably in around a week to 2 weeks. And then we move on to development for 4.0, where the OCI encapsulation of OCI containers into CIF images and continuing to improve the kind of feature set of this OCI mode are the main piece that we'll be working on. So the roadmap that we have for that is linked from the agenda items for this call. So if you want to see what's coming next after the things that I've talked about today, you can drop in here to 4.0 features and you'll see what we're going to work on. Because it's 4.0, it's going to be a major version, and we're going to take the opportunity to tidy up some of the command line too, which has gotten a bit complex. So some of the key stuff I showed is a bit complicated and inconsistent, and some of the ways we interact with remote servers are a bit complicated and inconsistent. So we'll be tackling those too. Okay, well, I've talked a lot today, which I suppose is the nature of the beast with this type of demo. Are there any updates, any things I can talk about, or any questions, any topics people want to discuss on the call? Okay, well, it's been quite a quiet one, but this will go up on YouTube too. So if anyone is watching it there and has any questions, please drop into our Slack or the Google group or anything else, and you can ask those questions there. We look forward to getting feedback on the new features we've added. And if you have any issues with those as you try the release candidate or after the release comes out, please do drop issues into GitHub, and we'll look at those as they come up. So thanks for coming along. We'll call the meeting for this month and hope to see you next month.